चैनल ऑक्सीजन टू लाइफ में आपका स्वागत है। जैसे कि हमने पिछले वीडियो में ट्रांसफार्मर इस विषय पर चर्चा की थी, तो इस बार इस वीडियो में विच टाइप ऑफ लॉसेस ऑकर्स इन ट्रांसफार्मर इस विषय पर चर्चा करेंगे। सो देयर आर टू टाइप्स ऑफ लॉसेस ऑकर्स इन ट्रांसफार्मर। लॉस in a transformer. So there are two types. First one is iron loss. Iron loss is also called as core loss. Second one is copper loss or I square R loss. So first of all we are going to study about iron loss. In iron loss, again there are two types. First one is eddy current loss and second one is hysteresis loss. So explanation about eddy current. Eddy current. The eddy current losses occur due to the flow of eddy currents. This losses is occur due to the flow of eddy current and flow of eddy current in the core of the transformer. Flow of eddy current in the core of transformer. Information about transformer I given in before videos. So these eddy currents are small circular currents. These eddy currents are small circular currents. Eddy currents are small circular currents. So which will cause the core of the transformer to heat, which will cause the core of the transformer to heat, which will cause the transformer to heat. So just because of this heating, the power loss in the form of heat. So the eddy current loss is given by and denoted by W is equal to beta Bm square F square T square V, and the unit is watt, where beta is constant and Bm is max flux density, and the unit is Weber per meter square, and F is frequency, T and T is thickness, and the unit of frequency is hertz, and T is in meter, and V is volume. and the unit of volume is, as we know, that is meter cube. So these are the quantity which are using in iron losses. So this now the second loss, that one is hysteresis loss. In hysteresis losses, the hysteresis losses occurs due to, means this losses occurs in, this loss occur in the core of the transformer. Transformer, in shortly we can write like this. So transformer, due to magnetic reversal, of the flux in the core, the power is dissipated from the heat. The hysteresis loss is given by again hysteresis loss is equal to eta b raised to 1.6 into F into V, and as we know the unit is watt, where eta is constant, Bm is equal to max flux density, and the unit is Weber per meter square. It's necessary to write the all information about the constant and the values which you are taking, so the examiner can give the full marks for our answer. So frequency and the volume, that is in meter cube. Therefore iron loss or iron losses is given by the addition of iron loss and the hysteresis loss, that is Wi is equal to We plus Wh beta Bm whole square F whole square T whole square V plus eta Bm 1.6 raised to 1.6 F into V, unit is watt. Now this is for the iron losses. So now the second part, that is copper losses. The copper loss occur due to the the copper loss is occur due to the ohmic resistance present in the both primary and the secondary coil, which we are studying before this video. In that I search about that primary and the secondary coil, and the primary winding and secondary coil, and the current passing through the primary winding which creating the flux, and the secondary winding which creating the flux, and the resistance which we are denoted in that core. So the copper losses are occur due to the ohmic resistance. Says occur due to the ohmic resistance. So that ohmic resistance is present in the both primary winding and secondary winding. If R1 and R2 are the resistance for primary winding and secondary winding, and I1 and I2 are current in primary and secondary winding. So total loss, that is total copper loss, can be write as Cu loss in primary winding plus Cu loss in secondary winding, that is Wcu is equal to I1 square R1 plus I2 square R2, or Wcu is equal to I1 square R01 or I2 square R02. So this is the equation for the copper losses, and for the iron losses is We plus Wh. So these two equations are very important for the examination. So if you like this video, then share and comment, and don't miss to subscribe this channel. If there are any queries, then comment in comment box. Thank you. Jai Hind. Good night.